The eye is the retina. And here's the very back of the eye, which is not unlike a black curtain or black screen, called a pigment screen. It's black. It's black because it absorbs whatever light gets past these sensory cells, so the light doesn't bounce around the eyeball like a fun house. And right up against the very back of the retina are the photoreceptors. These are rods, shaped like rods, and cones, which are attached to the sensitive. So the photoreceptors are lined up strangely, instead of pointing outward or they're pointing away from the road against the back of the retina. They do that though probably in order to keep us from having a distorted, unfocused field of view. I don't know if you've been to an outdoor movie, a part of a movie, free movie, that's shown against a building with brick walls, the building made white, and the bricks might be different depths. Some bricks are closer, some bricks are sticking out, some bricks are sticking in. And so the focal point of the film will be correct on several bricks, but it will be out of focus for those that are too far back and those that are too far forward. You don't have good focal precision across the whole retina, that your photoreceptors aren't all even. Well, they make it even, so we line them up against the back wall. So the photoreceptors are pointing towards the back of the eye of the string. And we're not the only receptors or cell types in the eye. So photoreceptors, rods, and cones are neural cells, they're part of the nervous system. They're not true neurons, they don't fire active potentials. But they are nervous system cells. They're neural. And there are a bunch of other cell types in the retina that the photoreceptors synapse on or connect with. I call them support cells. You don't have to know their name. They're part of the nervous system. Rods and cones respond to light, and they change their neurotransmitter output onto these other support cells. What happens in these support cells is important, but conceptually is all you need to know. What's happening here is a lot of convergence of sensory information to different degrees. You're very, very sensitive to light in the peripheral field of view. Even very, very dim. So you probably have this experience. If you are out in the countryside and looking over the starry sky, and you can see teeny tiny pinpoints of light, very dim, very distant stars. And then you see a star, and it catches your eye, and you look right at it. What happens to the star, this dim star that you see, and you look right at it? What happens to the star? Okay. It seems to do what? It seems to disappear. So there's a dim star you see out on the side of your vision, and you look right at it, it seems to disappear.